So in the video, we'll be starting with the transshipment and transportation problem. Basically, what we will be doing is we are shipping the goods from a source to a destination. So simply we're just transporting from one place to another. Let me just check the laser if it is available. I don't think laser is available. Okay. Okay. So just see this is the source M1. Let me just check if I have this laser. So in the transshipment problem, we are transporting goods from one place to another. So as you can see, the M1 and M2 are the initial source. They are the manufacturers in the case in these two on the left hand side. And the S1 and S2 are your intermediate sources. R1, R2, R3 are your retailers. So when we just connect to it a story, you can see that there are two manufacturers, M1 and M2. They are manufacturing a certain product. So they are located at some place. So from there they are sending the goods from their location to the location of S1 and S2. They are your distributors. Then the distributors are then supplying the goods further to your retailers. When they are transporting, they'll transport through a route. So transporting through that route will incur charge, will incur some cost. For this cost is given here for individual article. So say 75 items are produced by M1. You can consider them to be just milk packets. Just consider them to milk packets. So M1 and M2 are two manufacturers who are packaging the milk packets and sending them to some location intermediate nodes S1. S1 and S2. From S1 and S2, you are getting that to your retailers. So here what is 75 and 75? These two values are this is your supply. This is a supply which is being manufactured. And these values 50, 60, and 40, this is your demand at your retailer. So now if you just add your supply and demand, this is equal to 150 and this is also equal to 150. So here the supply is nothing but it is equal to demand. So this is the first case of transshipment we'll be seeing in this video. In the next video, we'll see where supply and demand are not equal. One is greater than the other, then how we should be solving. For this case, supply and demand are equal. So we are transporting them through these routes. So if you see from M1 to S1, there is one route from M1 to S1. There is one route from M2 to S1. And there is one route from M1 to S2. There is one route from M2 to S2. So here in between M1, M2, S1, S2, there are four routes. Similarly, for S1, S2, and R1, R2, R3, which is between the distributor and the retailer, we are having different routes. We have to identify what is the quantity we have to take from M1 to S1 and the route cost. And then from S1 to R1, R2, R3, what are the quantities we have to take and which path we should choose. So that is our main part. So who should be the main point of source for R1? And similarly, who should be the source from S1? So that is the basic part we need to calculate that we can calculate manually through many ways. But when we are doing it to LPP, it will be very easy to solve. So what is your basic objective? In this case, the cost is given. So when cost is associated, your objective is to minimize the cost. So let us just replicate this in Excel. While we are going deep into Excel, then we will be understanding it much better. So in Excel, I'm doing it from the start. So in the rows, I'm entering the sources, and in the column, I'm entering the destination. So here, what all are your sources? You see the paint. M1 is a source. It is source for S1. M2 is also source. It is source for S1 and S2. Similarly, M1 is source for S1 and S2. Similarly, S1 is source for R1, R2, R3. S2 is source for R1, R2, R3. So these four are the sources. They are sources to different nodes. So write all of them in the sources place. So M1, M1, M2, S1, S2. This is in the rows. The rows are the sources. Sources are in the rows and destinations are your columns. I have written the sources in one row. Destinations I'm writing in the column. So these are your sources. So what are your destinations? Obviously R1, R2, R3 are definitely your destination. S1 and S2 is also destination. How is it the destination? S1 is the destination for M1 and M2. Similarly, S2 is destination for M1 and M2. We're not checking in the as an entire whole. We are checking individual segment. Can it be source? Can it be destination? A single node can be both source and destination. So here the sources are M1, M2, S1, S2. The destinations are S1, S2, R1, R2, and R3. So we'll enter them also. So here S1, S2, R1, R2, then R3. Now these values, this is the cell. This cell is the cell takes the cost associated. Cost to take a good from the source to the destination. So if we look here, S1 is your source. Here M1 is your source. See, M1 is the source. From M1 to S1. S1 is a destination. So these are your destinations. These are your destinations. These are your sources. So from source M1 to S1, first we have to check if there is a path. M1 to S1, yes, there is a path. And the path cost is 5. So enter 5. Then from M1 to S2. From M1 to S2, there is a path. The path cost is 8. Enter 8. Then from M1 to R1, there is no direct cost, direct path. From M1, only S1 and S2 you can reach. You can't reach R1 from M1 directly. So there is no path. When there is no path and you are minimizing the cost, then the cost should be high. Why it should be high, we'll again confirm it in the next part. You'll understand as we proceed. From M1 to R1, there is no path. Since there is no path, you have to minimize the cost. That's why we are increasing it to 1000.
From M1 to S2, it should be 8, whereas it has been written.
Yeah, M1 to S2, it is 8, not 5. Sorry. Similarly, for M1 to R2 and R3 also, there is no direct path. So, then again make it 1000. 1000. Just not 1000 is not a fixed number. To make it a high number or a big number, bigger number. Then, so that the path is rejected. Then from M2, source is M2, M2 to S1. M2 to S1, the cost is 7. M2 to S2, the cost is 4. So 7, 4. Similarly, there is no direct path here. 1000. Then just drag it down also because there is no direct path. Then from S1 to S1, S1 to S1, there is no path. As in this case, there is no self path. So we are also avoiding this path. Now to avoid it, we add with the maximum value, which is 1000 again. S1 to S2 also there is no path, again 1000. S1 to R1. S1 to R1 the path exists and the cost is 1. S1 to R2 the cost is 5. S1 to R3 the cost is 8. So 1, 5 and 8. 1, 5 and 8. From S2 the same. S2 to S1 there is no path, 1000. Again 1000. From S2 to R1, R2, R3. So from S2 it is 3, 4 and 4 again. 3, 4 and 4. So this is one matrix. This matrix is explaining us about the cost. Now we need to know number of articles. Number of, in this case, the milk packets. Number of milk packets to be shipped in that route. We have said 75 milk packets are here. We don't know how many should come from M1 to S1. We don't know how many should come from M1 to S2. Similarly, from S1 to R1, S1 to R2, S1 to R3. We don't know that. But we know the variables here are similar to the matrix form. In that case, we just copy this matrix and paste it here. Then just put it all 0. So I'll just repeat it again. Just before that, let me make it 0. So here, once we have entered the cost, we want the variables. So in this case, what are our variables? Our variables are number of milk packets which are to be shipped, in the path. So if you starting making the variables, the first variable is M1 S1, number of milk packets shipped from M1 to S1. Second variable is M1 S2, 1, 2. M2 S1 third variable, M2 S2 fourth variable, S1 R1, S1 R2, S1 R3, S2 R1, S2 R2, S2 R3. So these are the variables which has to be formed.
So it's variable, but
M1 R1 is not where it will be zero. You cannot ship. There is no direct path between M1 to R1. So here also we will do the same because there is no direct path. Solver will not give the value. So instead of just writing the constraints in a line in a sequential format, we are using the matrix method. We have copied the same matrix. Solver will also choose only those values which a path exists. Now understand why we are using 1000 here. We are putting 1000. The solver will not use that path. Why? If it has to go through that path, the cost associated is 1000. Our objective is to minimize the cost. That's why we have put the weight very maximum. What is your objective function Z? Your objective function is the cost, total cost associated in the shipment. That is transshipment. Transshipment means shipping from origin first manufacturer to an intermediate node, then to a final destination. So your total cost or objective function will be sum product of the cost associated with the path into number of articles which are shipped on that path. That is your Z objective function. That part will give you the objective. So once we have entered the cost and the variable, we have decided what is the cost coefficient, what are going to be the variables, then we also calculated the objective function. Now we have to enter the constraints. So what are the basic constraints when we look at the question? The first constraint being values which are coming from S1, incoming values should be equal to the outgoing values, which means the number of packets which are coming to S1, they can come from M1 and M2. So suppose there are X and Y. These are the two values, right, which are coming to S1. These are the incoming. That should be equal to the outgoing values because S1 will not store anything. Whatever it is receiving, whatever ideally, what is the case? I have added a story to it. S1 is a distributor. Distributor, when he sources from the manufacturer, he has to send entire goods here. Since it is a milk packet, it will perishable goods. So whatever comes here has to go here. Similarly for S2. So those are two constraints, 1 and 2. So what all variables from M1? M1 they can go either to S1 or they can go to S2. So those values which are outgoing from M1, that is nothing but the source of M1, which is 75. It can't be more than 75. It should be less than or equal to 75, right? It can't send more than 75. Similarly, what are the values outgoing from M2? They are also less than or equal to 75. Less than or equal to. Because if here the supply is equal to demand, that's why we are equally we will be sending. If at all the demand is less than supply, then less than equal to will come. That's why I'm earlier itself saying less than or equal to. So this whatever is coming here in S2, this already we have discussed. So for S1, S2, we have two incoming and outgoing two constraints. M1 and M2, we have two constraints incoming and outgoing. And even R1, R2, R3 also we have incoming and outgoing. Whatever is coming in R2, it should satisfy the demand 50. We should not send more than 50. We should send less than or equal to 50. Why? If you send more than 50, there is no demand, goods will get waste. One thing, a retailer himself will not buy it. He'll only take only those for each he has a demand. Usually they take less also because they don't want to store those goods. So these are three more constraints. So 1, 2, 3, these are four total, 7 constraints are coming. So let us see how to put them in the Excel. So here, this is your source. The source is the supply. So write supply. The destination is the demand. So write demand. Now what I'm doing is I'll do the auto sum. I want to know how many units are at S1. Just see here, this is auto sum feature. Then just click on any tab, any cell, and select those cells for which you want to do the auto sum. I'm calculating all those values which are reached to S1, which are reached. Then I'm just extending it downwards like this. So this cell is giving how many milk packets have reached these destinations. Then for the supply, again do the auto sum. and select those cells for which you want total. Sometimes it will select extra also. Don't just deselect and select how many you want. So this is the number of cells which have started or which have moved out from the source. Now the constraint is from M1. M1 they're moving out. How many can move out from M1?
75.
M1 the total moving out is less than or equal to 75. So less than or equal to 75. Similarly from M2 also 75. For S1, this we'll do later. Now come to R1 and R2. I'll say why we come later. For R1 and R2, R1 I said it should be less than or equal to 50 because that is the demand. Again less than or equal to 50. Here again less than or equal to 50, 60. Then for this less
40.
than or equal to 40. Now this is satisfied. Now what is this one? This S1 is number of values which have moved out from the source. That is equal to number of values which have come to. So while we are entering in the constraint, we can just put this is equal to this value and this value is equal to this. So that we understand, I'm just giving it a color scheme. Let me just give it this yellow and this one also this yellow. So these both are equal. And for this cell, let me just put green.
And the summation of
And
S1 and S2
for
is
this
also
one.
150.
Summation of S1 and S2.
Is also 150. That one
Summation
also
of
we
S,
have-
that is already satisfied here, no?
We're saying the total summation of S1 as well as S2
Hmm.
will obviously be less than or equal to 150.
150.
If we,
That
because,
will also be a constraint.
so that is not a
No, we don't
constraint. That
necessarily-
is not constraint. Why? Because M1 and M2 we are checking 75. They did not state the capacity of S1 and S2. If they have said that distributor is not taking more than 100, then it will be a constraint. They did not give any constraints for S1 and S2 in the question. Suppose here for S1 they can be 80. For S2 he is only taking 40 because he thinks he cannot take more. Less than 150. It can be equal to 150, but that is not necessary constraint because more than 150 obviously can't come from M1 and M2. So we need not put
But
it.
this 80 plus 40, how will you meet the demand of 150?
They are not meeting.
Not.
They are not meeting.
This is not applicable. in
This is not applicable for our case. That part we don't,
We'll do in the next.
that part we can check it later. So just erase this thing so that there is no confusion. So now we have entered all those constraints and everything. Now simply go to solver. Solver, reset. Then your objective function is here. Here we are minimizing it, don't forget. These variable cells are over here. Then for the constraints, cell value, I was adding these. So less than or equal to the demand. Add. Then this is your supply. Less than or equal to these values. Add. Then these I'm adding. These both are equal. This is equal to these two. You can simply select. Need not worry there. This is horizontal, this is vertical. Excel will deal with all of that. Then okay. Simplex LP. Then simply solve. Solve, found a solution. There are no values have been solved. This has come because they have put the less than equal to symbol. From manufacturing, we said more than, even if you send 0, it is fine.
If you want to minimize the cost, don't send it.
Don't
Yes,
send it.
don't send.
Now we have to put equal to. That's why I have wantedly put it less than equal to. Then for this also, because you have to meet the demand. If I don't do like this, you will not think this is also a case. So just equal to, equal to, equal to. Then go back to your solver. Then wherever you have put less than equal to, you can just change it by changing the sign as equal to, then okay. Then the other part, click change. Need not do from the first, you can just change the symbols. Now click solve. Now you see, it is saying from M1 send all the 75 to S1. Why? From M1, if you see, M1 can send it to S1, M1 can send to S2. If you compare in that way, the least cost is 5. So it chose that path. In that part, it is sending the entire 75. So only M2. M2, the least cost is with respect to S2. It is sending this entire supply to 70 to 75. Then now M1 and M2 are having 75, S1 and S2 are having 75, 75 each. If you check the path between S1 and R1, it is 1. Then, so that's why the entire demand of R1, which is 50, is satisfied by S1. Since S1 still is having 25 units, it can either send to R2 or R3. If you choose see R2, the cost is 5 units, but with R3, the cost is 8 units. So it is sending the 25 units with R2. Now with R2, the demand still is 35 units, still demand is there. So though 35, it has no other choice but to get from S2. The remaining values of 40 which are at S2 from 75 minus 35, 40, those are sent to R3, which is the cost here. So that is the way, and this is the total cost. In this case, since supply is equal to demand, it is quite easy to do it. Where supply is not equal to demand, we'll get a good confusion where to put equal to and where to put a less than equal to and everything. So that part we'll look it up in the next video.